No one has ever embarked on the scale of what we're doing here.
In Australia, engineers are taking on an extreme challenge.
There's constant problem solving. Every day there's new problems, there's new issues.
Trying to clear suffocating traffic congestion by building an immense state-of-the-art metro through the heart of Sydney.
We have to get there, there's no other way.
The stakes are high.
You've got to take every bit of luck you can get, don't you, in this game?
This is, by far and away, the biggest public transport project in Australia's history. If I'm honest, I probably didn't quite know what I was getting myself into.
Ain't got a problem.
Sydney, one of the most recognisable cities in the world. It's got the Opera House, the Harbour Bridge, Bondi Beach, and traffic. Endless traffic. But that's about to change. Now a crack team from around the world is tackling the problem head-on, battling to build a world-class metro without bringing the city to a standstill. They've come from the UK.
Mega projects gets thrown around like confetti. What makes us different is just layers and layers and layers of mega.
It should just fit together like a really nice Meccano project.
From the US.
I'm here to dig tunnels. I'm here to do stations, excavations, you name it. I love it. Whew.
France.
The design for Sydney Metro is unique, a very creative design, only for Sydney.
Germany.
When we are tunneling under Sydney Harbour, there are no second chances.
And from Italy.
It's the future of mobility for this city.
40,000 people will build this metro, most of them Australian.
It's definitely the biggest role and responsibility I've had. I'm loving it.
I've personally developed and grown working on this project, and I think the whole team has.
It is interesting. Not very often you get to dig a big hole right in the middle of Sydney.
The hole James Pearce needs to dig is in the toughest location imaginable. Right in the middle of Central Station. The busiest rail hub in the entire country.
99.5% of Sydney trains travel through this station every single day. So it's a huge undertaking. We've got 4 pedestrian tunnels through the middle of the station box. And 3 of them we need to keep open at all times, 24 hours a day, 7 days a week, 365 days a year. The station doesn't shut down at all.
James has to remove more than 500,000 tonnes of earth. 6,000 tonnes a week. Without disturbing Central's almost 2 million weekly passengers. It's a highly complex task. But James is up for the challenge.
So here we are right in the middle. These platforms all need to go to let us dig 30 metres down into the ground and connect into the new tunnels, which will be the Metro trackway. So all these platforms, time to go. Pigeons out, we're coming in.
His solution is simple. If you can't go around the passengers, go over them with a truck bridge.
There's no access the whole way around Central Station. 230,000 cubic metres of material to come out. Every single truck movement for the project will be in and out over that bridge. One way in, one way out.
Right in front of the tower crane. The largest beam is 55 metres long.
James is only allowed to disrupt train services for 12 hours. So they're bringing in a prefabricated bridge. 400 tonnes of it.
And that's fully sealed, so then you can drop the concrete in.
It will be a race against time to crane in the gigantic steel spans. Right next door, lines will remain active, with 1,500 deadly volts that must be avoided.
Abutment B is extremely close to the live rail.
James backs himself and his team to get the job done before the Monday peak arrives.
It's going to be a totally different scene on Monday morning. There's going to be a whole heap of steel across here, and the trains will travel under the bridge for the first time.
Digging up the middle of Central Station is just one of the many enormous challenges that confronts the team. From here, one line needs to run north through a minefield of subterranean obstacles deep under the city, under the harbour, and 50 kilometres out to the northwest. Running south from Central Station, another line will swing 20 kilometres out to the southwest. Next, another line will leave the city and travel 25 kilometres due west to Parramatta. Yet another metro line will then connect a new international airport with the rest of the city. And further still, more lines will create a virtual metro loop around Sydney. More than 50 new or renovated stations need to be built, linked by the longest railway tunnels ever dug in Australia. This project is exceptionally ambitious, and it all needs to be constructed in just a few short years. At every turn, new complex dilemmas await. One such dilemma looms at a new station site right in the city called Pitt Street. Bobby Saying is in charge of excavating this station. He has to carve out two giant holes between the skyscrapers. No easy feat considering the cramped inner city location. Bobby's mission is to demolish, then dig.
There's a total of 12 buildings we're demolishing. There's a 14-storey building here, there's a pub in the corner, a number of 1 to 3-storey buildings around the rest of the site. There's also another 4 buildings at Pitt Street South. The access on the streets surrounding site are very limited. The hard part is actually getting that first bit of access so you can drive trucks in, load them, and then they go out. That's correct, yeah.
12 buildings bite the dust, but one must stay. It's 41 stories high and towers over one of the massive holes Bobby needs to dig. 76,000 tons of earth must be extracted right next to the building's foundations. If anything goes wrong, it could be a disaster.
We're about to dig down a really big hole right next to a 41-storey building. There's a risk that because that building relies on this ground for support, as we excavate, it will cause movement.
It's no ordinary dig. As Bobby's team descends in the skyscraper's shadow, they must shore it up from below with reinforced concrete walls up to ½ a metre thick. They'll work slowly but surely, inch by inch, to build a concrete rampart.
We can't take away the entire shaft material and then install the wall. We have to progressively do it as we come down. Otherwise, there is a risk of movement of this 41-storey building.
To make matters worse, Bobby's work sites are surrounded by bustling buildings and businesses. They all need to keep functioning while he demolishes other buildings and then digs his super-sized holes right next door.
This is fire station number 1 in Sydney CBD. Our site is located on the back face of this building. The busiest fire brigade in the Southern Hemisphere. We need to ensure that we don't block their driveways, that we're clean and clear around their site. They operate 24 hours a day, and therefore they have sleeping quarters there as well. So we need to make sure that during the sleeping times we're not creating a lot of noise.
On the other side, there's a pub.
It's also heritage listed, so a good reason not to demolish it, but it is a beautiful building, and I'm told it has a great beer.
There are places people want to enjoy a quiet drink, and places where people need to sleep.
This is a hotel, and so you have guests, and you need to keep them happy. And also, it's in our interest to keep our neighbors happy, because we have to work with them for years on end.
You can see them there, we're shot pretty all
Gloria
there.
Fernandez shares responsibility with Bobby for trying to get this station done. Keeping the neighbors happy is one of their top priorities.
Noise has been one of the bigger complaints, as well as dust. And so really, when we put this acoustic shed up, that actually had decreased the amount of complaints in that space. You know, it's not, we're just doing the work and carrying on. It's about working with the community and our surrounding neighbors.
Up to you.
This job is hard, but Gloria has the right spirit to overcome all setbacks.
As a project engineer, you look after everything, and that's what I love about, being in construction. I love project management, being across safety, engineering, design, quality, delivery, what have you, and that's why I'm here in this amazing project and in this amazing industry.
With a site cleared, it's time to start digging.
It's been going great. We're about 4 meters deep at the moment, and it's a total of 20 meters deep once we're done.
His main concern remains the 41-story building towering right over the hole.
As we excavate the shaft and we expose what is left there adjacent to the building, it's something that we have to look, assess, get our designers involved to ensure that what is there, it matches what their assumptions were, and so far so good.
So can Bobby be sure the skyscraper next door won't begin to lean in over his hole?
I'm very confident, and I'm very hopeful, but I'm very confident that everything will be under control and we won't end up with the Tower of Pisa.
The vision for Sydney's new metro is breathtakingly bold and far-reaching. This is the man responsible for it, Engineer and Transport Chief Rod Staples. He is both proud and often overawed by what he has set in motion.
No one has ever embarked on the scale of what we're doing here. This is, by far and away, the biggest public transport project in Australia's history. If I'm honest, I probably didn't quite know what I was getting myself into at the start. When it goes wrong, where do I go to blame someone? I go and lock myself in a room and have a good hard chat to myself.
Rod is actually not the first person to have championed a Sydney metro. Remarkably, the idea was originally suggested more than 100 years ago. The brainchild of this man, engineer John Bradfield. In 1915, Bradfield submitted a grand plan to government to revolutionise Sydney's transport infrastructure. Bradfield wanted to build a bridge across the harbour, electrify the trains, and create an integrated, efficient railway system, much of it underground, just as was being done in London, New York, and Paris. The First World War intervened, and Bradfield's plan was shelved. After the war, Parliament approved the plans for the Sydney Harbour Bridge, and the building of that John Bradfield icon began. By 1926, work had started on Bradfield's other vision for a Sydney metro. Some new underground city stations were built, but then work stalled. Beneath Sydney are almost 1.5 kilometres of unfinished platforms and train tunnels, the incomplete remnants of Bradfield's metro. During the Second World War, the tunnels did prove useful as bomb shelters.
Because these walls weren't here originally, they were put in for the air raid shelter, not for the railway.
The original vision for these tunnels, however, almost did become a reality.
So this platform completed nearly 100 years ago, even to the point where the tiling's in and some of the signage is up, but never, ever seen a train run through it. If you took yourself back to the 1920s in Sydney, it was an unprecedented amount of construction going on. People believed in Bradfield's vision and they were getting on with it. We get to the end of that decade, the bridge is finished, a bit of the plan for the railway is finished, and then the Depression hits. The money's not there. And then before we know it, World War II, and that's it, game over. The focus really turned to other things. Fast forward to the 1950s, car becomes a thing that everyone wants. And so the desire, the appetite to finish that plan disappeared. I just think to myself, wow, what a lost opportunity for Sydney. That really just drives me to say, well, let's go back and finish the job that he started.
Rod is on a mission. He is determined to realise what Bradfield could not. Rod's biggest problem was convincing his boss that a driverless metro was the best way forward for Sydney's future, after she had promised the community a more traditional railway.
That kind of shook me a little, and some bits of it were confronting, like driverless trains. Was this the right way to go? Is it the way of the future?
Rod was convinced metro was the way of the future. Convincing others was harder.
Transport officials, including Rod, said to me, "We don't think it's sensible building the same old kind of rail line. You've got to go for a metro."
The challenge for Rod and the team was set, but what confronts them is a city that has changed radically in the last 100 years. In Bradfield's time, the population was 800,000. It's now more than 5 million. The digging of Sydney's first train tunnels was a painstakingly slow and laborious task. Some were dug in the more traditional way, using drills, dynamite, picks and shovels. Holes were dug, walls built, and the whole thing covered over. Today, train tunnelling is a very different affair. Meet an extraordinary invention, the tunnel boring machine, a TBM. Sydney has ordered 9 of these. A factory in Guangzhou has just about completed the first ones for central Sydney. These mechanical beasts were designed in France and Germany. TBMs are gargantuan, intricate machines. Each one will take 6 weeks to build. When assembled, they weigh more than 900 tons. A single TBM can cost more than $15 million and can cost $1 million a day to run. One stretches more than 150 meters end to end. This is the very front of it, the cutter head. This wheel of steel, more than 3 stories high, slowly rotating, pushed by powerful hydraulics, will crush and grind the rock ahead of it. Openings in the cutter head let the crushed rock enter the machine. Conveyor belts then transport the spoil back all along the machine out through the tunnel. Coming up the tunnel, concrete segments. A robotic arm picks them up and places them against the rock walls 6 at a time. It creates a ring of concrete, then does it all again and again. As it inches forward like a giant mechanical worm, it leaves behind it a fully formed, completed tunnel. It's time to test that this one works. The machine is fired up and turned up to high. Overseeing 4 weeks of tests is Martin Bell.
This is just really proving that the machine's finished. The machine will do what we've asked. It's really designed to simulate excavating the machine without actually excavating, if you like. So we're doing a trial run of all the functionality. It's basically a mobile factory at the end of the day. Once the machine's built and running, then everything's like a sausage factory, is the way it's described.
Like a performance car, this TBM has been modified to help it go faster.
We've introduced TCI cutters to the cutting head, so they're a button cutter. Those cutters allow us to cut a lot further. They're better suited to the sandstone conditions and minimise the amount of cutter changes we need to do.
So, does it meet the specs? Did this TBM pass the test?
It's a high quality piece of equipment. I'm excited. I can't wait to put it together and put it in the ground. That's really what it's all about. And now it's the nervousness of putting it on the water and hoping that it gets off the water and gets to site. But yeah, it's a pretty proud moment. It's like being a father, I suppose.
That's one down and on its way. Back at Central Station, the clock is ticking. James Pearce and his team are in a race against time to crane in the giant steel girders of the truck bridge. He needs to get them in and balanced above the tracks before train services resume beneath. All around him, other trains keep running.
So the suburban lines are continuing to operate this weekend. The intercity lines are shut down for the possession to lift in the major steel trusses over the live rail. That has been shut. We've got 48 hours between Saturday morning and late Sunday night to do all of our work and hand back the rail for Monday morning to open for the customers.
There are 8 huge pieces of steel that need to be craned into place. And maneuvering them is very dangerous. 1,500 deadly volts of electricity is running through the nearby wires. This steel girder weighs 55 tons.
We're very limited to what we can do. We've had to install the biggest tower crane in the world to come in and lift over live rail so we can lift them in the modules. They're massive pieces of steel.
This girder is more than 50 metres long, but needs to be placed with millimetre accuracy.
They're landed on all of the works which have been constructed previously, so the bridge piers and footings, we drop the steel girders on and bolt it immediately.
One by one, ever so carefully, the giant crane lifts the giant girders into position. There's no room for error.
The space is as tight as it's been on any job.
Slowly, the truck bridge begins to take shape.
Oh, they're doing a great job here. There's one already in, another one to go, so pretty good night shift at this point, and then we come back later and do the decks on top.
Trucks are the backbone of any major excavation. Deep station boxes are being dug all around Sydney. So an extra 1,000 trucks a day have joined the city's traffic snarl.
1,000 trucks in and out of the city, normally with trailers, causing congestion, blocking intersections at traffic lights. It's just not a fun city to drive around anymore like it used to be.
Making sure traffic doesn't grind to a standstill rests on the shoulders of this man, Steve Jones. Even for this ex-British commando, it's a daunting task.
It's going to be really, really hard. This is going to be a massive challenge. This is going to be collaboration on a mega scale. So whether it's the Transport Management Centre that you see behind me, whether it's Sydney Trains, whether it's the ferries, everyone is actually going to have to come together, make sure there's minimum disruption across Sydney while we do it.
Steve is fighting a constant battle to keep traffic moving. In this room are 18 specialists monitoring roads, traffic lights, buses, trains and ferries. Each scrutinises their piece of the transport maze. They try to unravel problems that pop up minute by minute with military precision. In their arsenal, they have access to more than 10,000 CCTV cameras. This state-of-the-art nerve centre is the largest in the Southern Hemisphere.
This is our Apollo 11 Mission Control Centre. This is where everything occurs. This is the integration. And I say to everyone, for me, it's like that swan. So it looks elegant and everything looks calm around us. But, you know, underneath, there's lots of people working really, really hard to make sure everyone gets to their destination as smoothly as possible. So can you tell us literally what's happening now, Dave?
So we're just after peak this morning on a Thursday morning, which is one of the busier mornings somewhere else.
From this command centre, Steve can track the movements of hundreds of trucks every minute of the day.
Trucking and the logistics is absolutely massive. We're looking at around 1,000 trucks a day in that CBD. We do all of the planning up front to make sure that disruption is kept to a minimum.
Steve knows he needs to win this battle against congestion.
So whether you're delivering infrastructure on the battlefield, you know, it's about continuously improving, continuously testing yourself. There's a new challenge every day and it's testing me every day.
Steve has to be very careful of the powder keg of frustration already out there.
There's trucks both sides of the road. They close the roads for some time, so it caused a lot of problems with the traffic.
I understand they've got a job to do, and they have to do it for the metro, which will make things so much better for people in the long run, we hope.
It seems everyone agrees the metro could be a game changer.
I think it's the only solution. We don't have the space anymore to build roads. I'm hoping in the long run, the short-term agony will be well worth it in the long run.
Back at Central Station, James Pearce is in a battle of his own. Again, racing the clock. Until his truck bridge is up and running, he can't dig down. He can't get anything in or out. Once the bridge is finished, it'll be full steam ahead. Fully laden trucks passing right over the heads of train passengers, passing through Australia's busiest station.
So the guys have done a great effort getting the steel in. Next step, concrete. So there's a thick deck to go in here, which will enable the truck bridge to carry fully loaded trucks, both in with materials and out with spoil for the main Central Station works.
For James, there's one ultimate nightmare scenario. A truck crashing over the bridge and ending up on the live rail.
Probably not what we want for this job in the middle of Central Station.
A truck plummeting over the side would spell catastrophe, so the bridge has to be reinforced to withstand immense impacts.
Big, thick concrete barriers up the side, providing protection for all vehicles both in and out.
With the barriers completed, James's battle with the truck bridge has nearly been won. Around 35 kilometres from the city of Sydney is an area known as the Hills District. To build the metro out here, engineers face an entirely different set of challenges than in the city centre. Here, the issue isn't how to connect into an existing station, but where to put the new metro stations. Beneath these hills, Rod's team will dig the 2 longest rail tunnels ever dug in Australia. The length isn't the problem. The hills are the problem.
This big climb up and then being able to stay far enough north to get to Castle Hill was a big key part of the alignment planning. Whenever you're locating a station, it's a real sort of fine balancing act between the absolute best customer outcome and then what the engineers feel that they can deliver in terms of the depth of the station, the terrain, and also the sort of ground conditions and geology that's underneath.
The steepest gradient these trains can climb is about a 4.5% incline up or down. So the problem is, in hilly country, a station cannot just be positioned anywhere. If a station was to be placed near the top of a hill, for the train to get there, the platforms would need to be very deep underground. That's not a good result for customers.
You just want to be on the train. You don't want to be spending 5 minutes getting from the surface down to the train. So the shallower we could make the stations, the more attractive it would be.
The deepest station in Sydney is about 35 metres, and customers find it frustrating. So for Rod and his designers, finding the right route and placement of stations is a careful balancing act. They have to ensure the depth of each station and the maximum incline trains will travel to reach them is achievable.
Where to put the route and where to put the stations was a massive challenge, not just from an engineering point of view, but from a whole community point of view as well.
In this area, Rod has had to carefully manage community expectations. Rail has long been promised here, but never delivered.
People were crying out for it. There'd been decades of debate and argument about building this railway. And when I first stepped out there, I think a lot of people intuitively believed that, yes, this would help. But no one actually believed that it would happen.
Rod is making it happen. For him, there's no other option. This area of Sydney has the highest level of car ownership in all of Australia. Here, triple car garages are the norm. A metro here should eliminate 14 million car trips every year. People just need to leave their cars in the garage and instead travel beneath the hills and far away. Back at Central Station, at last the truck bridge is up and running. But James's real work is only just beginning. It's demolition time. Now 3 railway lines have to be dug up. And again, they've only got 48 hours to get the job done. From 2 a.m. Saturday to 2 a.m. Monday.
To allow us to build the Metro box, we need to remove 3 tracks. 13, 14 and 15.
Again, James is racing the clock.
It's a critical point with limited time. We get a 48-hour window, we'll turn off the power, relocate all the wires, and then we put it back in, turn the power on for commuters on Monday morning.
As darkness descends, the rail gang gets into top gear. James first needs to remove the old tracks and then lay new ones and new overhead power lines that will divert trains away from the platforms to be demolished.
48 hours, that's it. We don't have any more time and we need to get the tracks open for the customers on Monday morning.
The clock is ticking and the team are pressed for time. But they can't jeopardize safety. There are 200 people working here, surrounded by moving double-decker trains and live power lines. Some are just 4 meters away.
We're dealing with live rail, we're dealing with buried services and signal cables, we're dealing with turning the overhead wire back on and the reinstatement of it. It's a huge piece of work compressed into 48 hours.
As Saturday ticks over into Sunday, there's still an enormous amount of work to do. Soon there's only 22 hours to go. Time is rushing by. Moving the overhead lines is one thing that can't be rushed. All the surrounding lines are still active. 1,500 volts courses through each of them.
We actually need to relocate the track and the overhead wiring. So all of the guys here are working together to do it safely, but we do need to recognise live power on both sides, very specific controls on both the cranes, excavators, and with all the people doing the work.
Finally, the old track is gone, and as night descends again, time is running out. The pressure is building. If they don't finish in time, there will be nowhere for trains relying on these 3 lines to go. Monday peak hour will be chaos. Then a strange-looking machine is brought in to speed things up. It's called the crab walker, and it's obvious why. To save time, the new track is prefabricated off-site, and the crab walker lifts it carefully into place in large pieces.
The crab machine or the PEMLEM comes in and speeds it up rather than laying every sleeper by sleeper. The new section of track gets picked up outside the alignment, the crab walk across, drop it into place, and then we tie it in and reinstate the ballast and tie the track in, open it up and away we go. We've got about 2 hours to go, everything's on track, no pun intended, should be right. And the trains will be in a few hours, back for Monday morning peak hour.
They make it with 2 hours to spare. About 160 kilometres from Sydney is the port city of Newcastle. It receives thousands of trade shipments from around the world every year. And now, the gigantic TBM components are starting to arrive. Some of the modules of these monster machines are extremely large. The cutter head alone weighs over 100 tons. This shield weighs over 200 tons. After the 8 separate hard rock TBMs are offloaded in Newcastle, these huge pieces of machinery will be transported by road to 4 different launching sites around Sydney. This part of the delivery has been months in the planning, but will need to be executed precisely to succeed. The first 2 TBMs travel to a site in Bella Vista. The next 2 will be launched at Cherrybrook. 2 more will travel to Chatswood, and the other 2 to the inner city suburb of Marrickville. The best way to achieve this is with a convoy of trucks. Like a military operation conducted under the cover of darkness, the convoy sets off. 1 TBM equals 900 tons of gear, which equals 23 trucks. Along the route, police and emergency vehicles clear the roads ahead. The route has been carefully mapped out to avoid weaker bridges that could be severely damaged by such heavy machinery, and those that are too low for the trucks to fit under. Some are cleared with little to spare. The further into the Sydney suburbs they get, the harder it gets. Again, time is running out. With rush hour just a few hours away, the convoy is under increasing pressure. As the streets narrow, every metre is hard won. There's danger on all sides, but safety is paramount. Power lines have to be lifted by workers, parked cars dodged. It's an obstacle course. One wrong move and the whole convoy could come to a grinding halt. Luckily, these are no ordinary trucks. This rig has 132 tyres. To navigate some of the tighter turns, another prime mover needs to steer the trailer from behind. The drivers behind the wheel, highly skilled specialists with nerves of steel. The convoys reach their destination just before peak hour. All the components are offloaded. Now they work around the clock to get the machines up and running so the all-important tunnelling can get underway. Back at Central Station, all train services are back to normal. Australia's busiest station is again running at full steam. In the middle of it all, James faces his next challenge: removing 3 train platforms. They're in the way of the cavernous station box he needs to dig. The problem is, parts of the platforms have heritage elements. He can't just bulldoze it all.
So the first thing to go is going to be these timber canopies, beautiful old timber, individually bolted and fully truss frame. Not very often you get timber like this anymore. All of the signs, all of the clocks and everything in here is heritage and well worth preserving. We'll do our best to look after it.
Platforms 13, 14 and 15 disappear. Platforms 13 and 14 will later be rebuilt when the new metro has been completed below. But one platform is doomed and will never be seen again.
Platform 15 is gone. It'll go 12, 13, 14 and over to 16 on the suburban line.
With all train services at Central Station now back up to speed, James and his team are again surrounded by live railway lines. From here on, nothing will be switched off to assist him.
We've got the intercities live and we've got the suburbans live. So we're working with cranes, excavators and pulling down pretty big buildings as well as demolishing in the middle of the live rail. The railway isn't switched off for what we're doing and we're doing this all in a very constrained space.
As the heritage structures are pulled apart, problem after problem needs to be addressed.
There's existing lead dust in there, which has been there from the train brakes over a number of years. There's services throughout them, which we have no idea where they're running. In addition to that, it's a fully bolted truss frame. So we're really undoing 60 to 100 years of history in the turn of a bolt.
Soon, this part of Central Station is consigned to history. Currently, there are only 3 ways to cross the harbour. The bridge, including rail, a road tunnel, and the ferries. The new metro will revolutionize this situation. For the first time in nearly 100 years, Sydney will have another rail crossing of the harbour. 2 new rail tunnels will be excavated deep under the harbour and join with a brand new station called Barangaroo. This underground station needs to sit on the very edge of one of the largest and deepest harbours in the world. And all of it will be below sea level. One of those responsible for making this station happen and safe is engineer and design manager Ali Shad.
So this is our station that we're designing here. It's about 240 metres long and 25 metres below ground, and it's about 20 metres wide, so it's a really big station. It's basically an iceberg station, so it's a lot bigger below ground than it is above. All of this is below the water level, so the harbour's just there, and all this is below that.
Being below water level right next to the harbour is a major challenge in designing this station. Ali is well aware of the risks.
See this wall here, it kind of just jets out, it kinks out there, and then it kicks out again. We have some unique challenges in regards to the location that we're in, but also some brilliant benefits. I mean, we're the only metro station that's going to take passengers right to the harbour front. That's just incredible.
To his credit, Ali is determined to see the positives. But this station's proximity to a huge amount of water is a construction risk. Not just in terms of the water in the harbour, but the water in the ground. The water seeping in through the rock.
The water level is basically above where the station's going to be. The station's going to be in a big hole in the ground at the end of the day. And so we've got to design for the groundwater, which is trying to push, in effect, the station out of the ground. Not to be too dramatic, it's not going to float away down the harbour, but the buoyancy effect would cause the station to rise out of the ground.
One solution to this buoyancy problem would be to have a sump, a low point from which all the groundwater seeping in could be pumped out. But Ali and his team have decided they cannot rely on this solution.
The problem with draining the station is, close to the harbour, we're just going to be pumping and pumping and pumping for the next 100 years. And also, if there's any nasties in the soil, then you're going to have to deal with them as well.
To make his station completely watertight, Ali plans to wrap the entire immense station box in plastic, without a single gap through which the water will be able to get in. It's known as tanking. But it is rarely attempted this way. And it will magnify another problem. With nowhere else to go, the pressure of the groundwater will build and build. It will eventually begin to push the entire station box out of the ground.
Tanking has its benefits, but what it means is we have to lock the station into the ground. So to do that, we've got all these, what you can see on the screen here, all these permanent anchors. These are really big anchors. They're up to 20 meters long. They contain 49 strands, and each strand is about the size of a AA battery. So in effect, each anchor is about 30 centimeters in diameter, 20 meters deep, and that's what helps lock the station into the ground.
Ali is placing his faith in the power of steel to hold back the power of water. To make things even harder, he's not just battling a water problem. His station is very much caught between a rock and a hard place. On the one side is the iconic harbour, and on the other side is a considerable wall, and a heritage one at that. This formidable rock face is part of the so-called Hungry Mile, a name bestowed by harbourside workers during the Great Depression. Last century, this place was crowded daily, with hundreds of men walking from wharf to wharf seeking work. If they found it, they put food on the table. If they didn't, they went hungry.
So this area's got heaps of cultural and historical significance for us, and we've got to be really careful that we don't impact that negatively in any way. So we really want to make sure this Hungry Mile wall doesn't fall in when we're doing our work.
The highest part of the Hungry Mile wall is about 10 meters. The station box needs to be dug right at the foot of this wall, 25 meters straight down. The end result will be a sheer drop of 35 meters. Needless to say, the team want to be sure the top of the wall is rock solid before they turn this into a high cliff.
We want to make sure that the wall's stable, and it's already about a 10-metre high wall, and we're going to be excavating another 25 metres down, so it's going to be 35 metres in total. We want to make sure that it's a good, solid, sturdy wall.
The geotechnicians get to work, drilling cores deep into the rock face. They discover it is definitely not as stable as it should be. They insert rock anchors, which should stabilize and add strength to the wall. It also needs to be covered in mesh, so rocks don't fall on cars passing below.
We've done the analysis and we know exactly what we need to do. So we're going to put in some anchors, some mesh, so we protect the wall and make sure that the cliff face is nice and sturdy.
Digging down can now begin, except for one small impediment.
We're planning to build a station directly underneath the operational Hickson Road, but we want to keep traffic running. So what we decided to do was build a temporary bridge deck to move the traffic over onto a bridge, and that allows us to then dig up the road and build the station, excavate completely underneath it.
The new road takes just 7 weeks to build. Finally, the station box excavation gets underway. Not long after, work grinds to a halt. Yet another predicament emerges from the mud.
But we found the oldest Australian-made boat. It's a pretty impressive find.
See where that hole's been dug over there, next to the hull? That's where we got the keel.
Marine archaeologist Cosmos Coronius is excited by the find.
This wreck is the wreck of the earliest known Australian-built ship that we have in Australia. We think it was built around about the 1820s or 30s. It was probably dragged up on what was once a beach sometime in the 1840s and eventually covered over the decades and finally covered over around about the 1890s.
Cosmos's work proves the boat was built in Australia based on what it was built from.
It's made out of Sydney blue gum, stringy bark and spotted gum, so local timbers. And that's what helped us conclusively say that it's an Australian-built vessel. This is a floor timber. It's one of the strongest timbers they have on the boat, and what they've done is used the natural curve of branches to make that timber. So they were very skilled at what they did with the little that they had.
Cosmos wants to excavate the entire boat and plans to remove every last piece so he can study this ghost from Sydney's past in detail.
We always knew there was a high likelihood of finding something, we just didn't know what. So we plan to work around it, just so it doesn't hinder our progress of the station build.
The boat is a wonderful find for archaeology, but risks hindering the Barangaroo team. Every day the archaeologists work is a day lost excavating the Barangaroo station. Ali puts a brave face on what is for him an unexpected situation.
It's a bit of a pain, but it's the right thing to do.
The right thing to do, perhaps, but the schedule has just gotten a lot tighter. This historic discovery risks delaying Ali and the team's progress. Work might have stalled at Barangaroo, but tunnel boring machines wait for no one. Time for action stations. Time to fire up the mechanical monsters and launch the TBMs. The high-risk job of digging 61 kilometers of tunnels is underway through sandstone and shale, and down to 58 meters at their deepest point. Hundreds of tunnelers working around the clock in giant underground mechanical factories where there is danger at every turn. TBMs are only ever given female names, a long-standing tunneler convention. Working in the underworld, they're a superstitious group. At every dig, there's a statue of Saint Barbara, the patron saint of tunnelers, providing protection.
Well, you've got to take every bit of luck you can get, don't you, in this game? It's high-risk construction. We'll take every bit we can get.
The 8 TBMs that have launched will dig almost 60 kilometers of tunnels, but not those under the harbour. The 2 tunnels beneath the harbour are the shortest any of the TBMs will dig. It's less than a kilometre from Barangaroo to the North Shore. It may not be far in distance, but it will be by far the most challenging and most dangerous tunnelling on the entire project. The team is about to discover what really lurks beneath the surface. Next time, the TBMs fire up on all cylinders.
Where the guinea pigs really so.
Skyscrapers in the middle of Sydney need to go.
The biggest challenge is for the 28-storey building.
And a TBM weaves its way through narrow city streets.
You need to get the TBM